Hello everybody, and thank you for joining me today for this webinar on how to use DJI Terra to process LiDAR data. My name is James Pick and I am the Head of Survey and Construction at Copters, and my journey began over 10 years ago at Newcastle University, where I did my final year dissertation in drones, and for the past 10 years been working with survey and construction businesses to get the most out of their drones and sensors to produce the highest quality of data sets for their scopes of work. Now, today we'll be obviously looking at DJI Terra. Now, some of you have probably already got experience with DJI Terra in the past, utilizing its photogrammetric processing function, and like DJI Terra, it's very fast, it's very efficient, and produces some high quality data sets from it. And that's not just being utilized DJI drones. You're free to put other third party drone data sets in there as well. But today we'll be mainly focusing on the LiDAR processing for it. Now, things we're going to touch on, we're going to look at the point cloud density in terms of adjusting that and how to get the maximum point density from our data capture, how to optimize that data set in terms of the point cloud accuracy, what sort of deliverables we can achieve from it and export from DJI Terra, like our digital elevation models, our classified point cloud, as well as OBJ meshes. And also look at some of the functionality which happens behind the scenes of DJI Terra, which other software packages don't do, like the ground classification. Now, when it comes to LiDAR, there are many applications for that, but typically we always look at being able to penetrate through vegetation on it, utilizing it in a rail environment for, say, example, embankment surveys, but also looking at it from a power line, power transmission point of view, surveying power lines, things like line sag, that kind of thing. So many applications LiDAR can be utilized in. So here we have the Zenmuse L2. This is the latest generation of LiDAR sensor from DJI. Some of you may have already been L1 users, but the L2 is the latest version out. There's some improvements from the L1. So first of all is the RGB sensor. So the RGB sensor utilized on this is the one which is used on the Mavic 3, the 1/4 of an inch sensor. It's a much bigger footprint. Also, in terms of the point density, is massively improved as well. But as well as that is the return rate from it as well. So you may remember from the L1, it was a 3 returns, and on the L2, it's a 5 return. Now, why is that important? What does that mean for me on the ground if I'm going to conduct a survey? So in terms of if you were flying over a heavily vegetated area, then with having 5 returns from it, you greatly improved your chances of being able to get through that vegetation to produce an accurate ground surface model. Also in terms of the accuracy, which is massively improved, so with the L2 we have 50mm accuracy across the X, Y and Z as well. So the L2 is a brilliant LiDAR system, very easy to use, massively improved from the L1, which can be utilized across various disciplines and applications. So what we're going to learn today in this webinar, so there's some key features we're going to look at. We're going to look at how we set up that job for when we're utilising it in the UK. So we're actually going to set it up in the UK coordinate system, which is OSGB 1936 and the ODN height. We're going to look at some of the features in there as well, like the cloud smoothing. When do we have this on? When do we turn it off? As well as using the correct range from that LiDAR sensor. You know, from ourselves who have used probably other survey pieces of equipment, what settings we put in that in terms of the processing side to get the most accurate data from it as well. And I'll share with you my 10 years of experience in the survey industry and offer any hints and tricks along the way for you to get the most out of your sensor. So I just wanted to address first of all some common misconceptions which I've heard about LiDAR over the years. So typically previous LiDAR sensors, they were a very high cost. I'm only going back 5 or 6 years ago where somebody was interested in an entry-level LiDAR system, and it was always around the 50k mark for basic LiDAR sensors. And that's drastically come down in cost now with the Zenmuse L2 range, where you can get one for sub £10,000. There's also in terms of the renewals when it comes to software processing as well, which typically was in the thousands of pounds for any renewal after that initial 12 months. With DJI Terra, that's not the case. It's very cost effective and a manageable renewal fee going forward, so it keeps that ongoing cost down. Also, there's a very steep learning curve previously with LiDAR sensors. So I remember operating LiDAR sensors where it was almost a dummy payload onto drones, so that had to sit independently of any of the internal fail-safes. With the L2, all that information is cast down to you live on screen, so you get the live point cloud, you get, have I got an RTK fix through? And we all know DJI do what they do very, very well is that user friendliness, that plug and play of sensor out the box into the port at the front, and then getting all that feedback from the sensor on screen in flight, which is really, really important when we're doing huge surveys, that we can QA that data whilst in flight as well. And the complex data management, I remember older systems as well, that was, you'd get various data sets from the LiDAR, from the RGB sensor on it, and you had to manage that, merge data sets together, manipulate it to create a finished article. With the combination of the Zenmuse L2 and importing that into DJI Terra, it's a very fast, easy, manageable solution where all one flight is saved into one folder. And we'll take a quick look at that afterwards before we begin of what that structure looks like. And also complicated. Software packages for LiDAR can be complicated. They can have lots and lots of settings which people don't even touch or maybe even understand what they fully mean. DJI Terra does this for you, so it's a very, very easy to use software package where everything's neatly laid out for you. There's not loads of settings and windows to go into. It's a very simple, straightforward process of data in, change the settings, change for that particular job, and then see what comes out the other side. So there's not a complex toolbar for it. It's a few clicks here and there, and you get that desired outcome out the other end. So when it comes to the workflow of flying the L2, so the operational plan, and this comes before we've even got the drone out of the box. This is done beforehand when that particular job comes in, and we do a risk assessment. We look at the area, we look at that specification we might be working to, and we gear up that flight akin to what kind of application we're doing, what's our desired result at the other end of that, and what kind of tolerances we're working to as well. So that's before we've even got the drone out of the box. Then it comes to the actual LiDAR scan of the mission as well. So that's done very easily through DJI Pilot 2, and anybody who's utilized any DJI platform before, once you're in that DJI ecosystem, it's very, very, very easy to use. All your settings are in there. A few little plays of the flying height, the speed, that's all done for you. Very, very easy. So when it comes to, say, planning a particular flight, I like operating that L2 at around 55 meters. That gives us around an estimated point density of around 200 to 300 points. So when I mentioned about spec earlier, that is really useful bit of information to take, and basically, will that give me my desired results at the end of it as well? So we set our flying height, we have that live on screen to give us that estimated point, and really then DJI Pilot 2 will do the rest for you. We'll set the optimum speed, and then from there on in, all we have to basically do is move on to the drone data acquisition, which is once we've planned the flight, press go, do our pre-flight checks, and allow that drone to collect that data for us. So us as a pilot, as a surveyor, we're really there just to make sure the drone's doing what we've told it to. We can be reviewing that data in flight by viewing the live point cloud coming through. That's fully colorized. After the flight, we can also do some basic measurements in the point cloud data as well. So if we are interested in getting information live whilst in the field, we can do that as well. And as mentioned, that the data management side of it, that all that data is written to an SD card on the LiDAR sensor, which we can easily take out, put onto our computer, copy it over, and import it into DJI Terra. So very fast, very efficient, can easily be done by anybody wanting to operate these kinds of equipment. So this is just an example of the raw data. As mentioned, we take the data out, we put it onto our computer, and all our raw data sets are saved in there. So we've got our RGB imagery for the colorization, we have our IMU file, we have our lever offsets, which traditionally we'd have to measure by hand. That's all done for you, and all that data saved on that folder structure for you to be able to just import into DJI Terra. So over to the demo, where we'll be going for a run through of processing of some L2 data. So as you see, once you open up DJI Terra, it's a very clean interface. There's not loads of options or loads of boxes to click. It's basically all there ready for us to start operating. So for ourselves, we can click New Mission, and we're going to be processing through some LiDAR data today. So we name it, click OK, and then we slowly start working down this right-hand side of the screen here. So we click Folder, go to the right folder we're using, and we select that folder. So all that data, all them raw files we saw before, have been imported into DJI Terra, ready for us to start processing. And as I say, we work our way down this right-hand side. So we can, if we want, if we was using a third-party base station or and setting up over a known point, we have got these options in here to coordinate that known point and utilize that and process our survey all relative to that point. But on this particular data set, we was using the network RTK, so no need to do that in here. So first of all, we drop down this next toolbar, and then we click myself. I go on to percent. Now I want to keep all the data, all that raw data we captured. I want to produce the highest possible point density from it. So I click on percent and leave that as high. And then on the following side of it, keep this on the point cloud processing. There is another option on here where you can perform a LiDAR calibration if you wish. That might be if you've processed some data before and maybe some of the colors off in certain areas, there might be some stepping in the data. That might be worth you then to actually do a LiDAR calibration for that. But for this one, we are going to go through the point cloud processing. So down to this point cloud and processing toolbar, you can see there's only a few little boxes to tick and click as well. Now for that particular LiDAR sensor, as I said, I typically fly this at around 55 meters. So as when we're operating similarly with other laser scan systems, the further we move out away from our LiDAR sensor, that data integrity is reduced. So typically if I'm flying at around 55 meters, I want to make sure that the data I'm utilizing is within that high tolerance, high accurate returns from it. So I changed this to 100. So anything outside that range, it's going to remove and not use it in the processing side. For ourselves, we are utilising this in a survey application. Make sure that you've ticked this optimised point cloud accuracy. Will increase your processing time, but it'll be a few minutes. And all we always have to remember at the end of the day is we want the highest possible quality of data set. So always make sure that this is ticked. Now this next option, the smooth point cloud function, you may want to keep it on, you may not want to keep it on. Now a couple of scenarios where you may want to turn it off. So the smoothing point cloud produces a cleaner, thinner data set, but it does, as the name suggests, smooth over parts of the point cloud. So you can imagine if you were flying over, let's say, a pitched roof, over, say, a townscape, then what the software will do is if you've got these rigid features which are important and you have the smoothing on, will slowly bevel them and remove some of the point cloud from it. If you want to keep them in and maintain the integrity of that particular feature, then turn it off. If you are doing the typical topo around, say, for sort of land management or topo for terrain, you may want to select this just to produce a cleaner point cloud at the end of it, but it will reduce and take some of them point clouds out of it as well. So I'm going to put it in this one. Now, what DJI Terra does also is it will classify that data. So as previously mentioned, LiDAR's a great tool to use when you're wanting to penetrate through vegetation. You want to get through that forest canopy. You want to create a nice bare surface model at the end. And DJI Terra will do that for you with minimal input from the user. So click on the point cloud classification tool, and there's these few options in here which you can adjust in terms of what kind of environment you're working in. So the environment where I was working here, this was a flat ground. We can toggle these settings as well at the end. And I wanted to produce the digital elevation model as a GeoTIFF at the end. So that's going to produce a DEM with all the off-ground data sets removed, like buildings, trees, cars, and just leave us with a data set with all them stripped back. And there is an option also where DJI Terra will draw contour lines in as well, and you can put these in depending on what kind of spec and tolerance you're working to. So because we're working in the UK, then there's a few options what we would change here. But first of all, there is this accuracy and control check. So if any of you have processed photogrammetric data sets before, you will put down some points on the ground, which you can see from the imagery. You'll survey the center of them points in, let's say with a GPS rover, and you'll import that data into, say, DJI Terra, select the center of that target, and utilize them points in the processing side. So DJI Terra, when it comes to the LiDAR processing, you might want to do something differently. For example, I use highly reflective targets, so I can see them in the intensity values and select that center. But one thing to remember when DJI Terra is utilizing these points is merely a check. It's not adjusting that data to the point at all. It's for you who is processing that data to validate that data and make sure it's within the specification you're working to. And typically for utilizing that at, say, 55 meters, then we'll be looking for an XYZ of around that 50 mil. So because we operate in the UK, I changed this to OSGB 936, and the important thing is the high is ODM. You will see above this there is also this arbitrary coordinate system. So in the past we have had businesses who operate on rail, and certainly in the UK to the snake grid coordinate system. So you can create a calibration file in there using the snake grid parameters, and then save that as a calibration file. So if you are operating on a particular point of the network, then you can just keep upgrading and uploading that JSON file, so you don't have to keep doing the calibration each time. It will reproject that data set using them parameters. And when it comes to the point cloud itself, then I select LAS, a universal point cloud format, which the majority of third-party softwares can utilize. And I also like to merge the data set. So I've got one point cloud at the end of this, which has been colorized, easy to manage. I can easily then drop that into a third-party software and do any further data analysis or processing. So once I'm happy with these results, I can click the start processing. I get a checklist just to double check that I've selected the right things on it, and then I click go. So you'll find DJI Terra is very, very quick, and also LiDAR itself is a much faster processing than photogrammetric workflow. So whereas you might have been waiting hours before for your data sets from photogrammetry, LiDAR is a lot faster, even across large data sets. So I'm just going to go through to the data set now, which we can view. So this is the data set which we've just processed through. This is a compound of construction companies. So you can see you've got this now colorized point cloud data from the L2. We can take a little bit of a closer dive then to see the results from it. So this is flown in around 4 or 5 minutes, and we can look at the quality report afterwards in terms of how good the statistics from that, say, this data set is. So very fast and efficient to collect the data. What we're viewing now is the RGB, but we can also toggle things like the reflective values, so the intensity, and you can see it picks up things like the center lines here, and some of these white markings across. We can also allocate to it a color ramp, so in the Z, this. And also a nice feature of these returns, we can view how well the data or that LiDAR has penetrated underneath this vegetation. So on this particular server, we'd set it to the 5 returns, and we can review underneath this tree line of what returns have come back to us. So you can see quite a few of the 3 returns, and in certain areas you can see the 4 and the odd 5 there as well. So it just gives us that little bit of further information when we post-process these results to see how well our data set is. Now, as mentioned previously, the DJI Terra will classify this data set as on and off ground. So when we click on this type, So Terra's done this all for us. It's classified our ground levels as ground points, and anything above that or anything off that as not classified or off ground points. So all these man-made buildings, all these vehicles across the road, also the trees, it's removed them. Now, if I turn off and toggle that, so you're just left with the ground points, again, you've got a nice clean data set there, and you can see where it has actually got points through, so for all this vegetation. So really, it's done really well in this very heavily dense area around here, which you couldn't send an individual in to survey that, but yeah, the LiDAR has got points underneath that vegetation. There's also a few more tools within DJI Terra itself. So there is a measurement tools. So typically, like in Terra for process through photogrammetry, you have the basic functionality of coordinates. You can take measure line points, as well as surface area and volumes as well. There's also a nice tool for doing cross sections in. So if I select this profile tool at the top, we can actually see how well it's done for across this vegetated area here. There we go, so we see that nice clean surface level here. If I do you another one, you could be able to see, for example, the camber of the road. There we go, that road level there. And you can also take measurements within this cross section as well. That's the functionality in DJI Terra. We can also review the DEM as well, our GeoTIFF. So that's left, I said, removed all them above ground objects and left us with a GeoTIFF. And then within also here we can actually review our quality report as well. So it gives us the statistical accuracy from it of how it believes the data set, how good that data set is. But just an example of how fast this processing was. This was nearly a 4-minute survey, and that was all processed, as you've seen there, in 7 minutes. We've also got the information on our output parameters, what kind of algorithms we run out, if we did put the smoothing on or the accuracy checks. And this would be where if we did put the accuracy control on it, we'll get our deltas in here of how good that is in comparison with them points we've surveyed as well. So just a report there which we can either include in any deliverable handover or just use it for our own reference should somebody ask for it further. So that's DJI Terra. That's how it works really well, nice and easy for it. So what we'd like to include here, so if anybody is interested in the DJI Zenmuse L2, what we want to do as a business, we are very high on support. So anybody interested in the L2, to make sure that you get the most out of it, you'll get a 6 months free license to DJI Terra, as well as a 30-minute one-to-one online training session with myself to make sure that you get the most out of it. As I said, I work for Copters. We are a full 360 solution in the UK, offering the wide range of DJI products, as well as their sensors and softwares. And we've been doing that for the last 9 years now, working very heavily with survey and construction businesses, making sure that they get the most out of their investment, making sure that they're producing the highest possible data sets. Support is key here, and something which we do really well at Copters is making sure that you guys get the most of it. Thanks for joining me today, and if you have any questions, please let me know. Thank you.